Going on, guys? We have this question right here. It's asking the force in members to find the force in members DE and DL and ML, right? So if you see the picture, this is DE, DL, ML. So in this kind of question, what we have to do is we have to just cut this part off, and we can take either this part or this part to calculate this force. So first of all, we know there's a force acting here and here, also here. So let's say this is AY, this AX, and this is IY. So if you see, uh, we have two unknown variables right here. Here's one, so I will calculate one of those first. So if I take moment around A, the two will cancel, so I can calculate IY. So let's do that one first. So if I take moment around A, so the total moment is 0 in statics. So I take counterclockwise positive, and if I solve for this one, so if you see 12 is uh, so all of them are acting downwards, so it means it's pushing this object clockwise, therefore all of them are going to be negative. So if I start from the first one, it's going to be minus 12 times 4 minus 12 times 8 minus 12 times 12 minus 12 times 16 and minus 12 times 20 and minus 6 times 24. Then we have Iy acting upside, so it means it's turning the object clockwise, therefore it's counterclockwise, therefore it's positive. Iy times that same distance is going to be 24. So from this one I can calculate Iy. It comes out to be let me calculate this. So it comes out to be 36 kilonewton. So 36 kilonewton, since this is positive, so we know this is acting upside, and I can now find Ay using vertical components. So if I take total Fy equal to 0, let's say upside is positive, and if I solve for Ay, it's going to be 6 minus 6 minus 12 minus 12 minus 12 minus 12. So we can simply write 12 times 5 minus 12 times 5 minus 6 times 2, or you can write like this, same thing. So and A is acting upside, so it's going to be positive Ay. So when you solve this one, you will get, and also Iy is positive, so we have to put Iy is 36. So since you solve this one, you will get Iy is equal to 36 kilonewton. Ay is equal to 36 kilonewton. So both are equal forces acting on it. You can directly, just by looking at this picture, you can guess it, because all of them are equal forces, so therefore it's equal. And you want to calculate Ax, you know sigma f of x is equal to 0. So that is Ax is the only horizontal force we have, so we know uh, Ax is 0 because that's the only force. So we have calculated everything, and then now I'm going to draw this part right here. separately. So it's gonna be like this. And this is B, A, and this is D, M, and we have some one right here. It's N, C, and we have these things here. So that's all we have, and we know AY is acting upside, and then we have, so if I calculate, okay, wait a minute, this all negative, and I have, okay, I'm right. So this is AY acting upside, and we know there's a force acting from this direction, there's one coming from this direction. Like direct, you don't have to worry about the direction, because when we calculate, if we get negative, it means we got the wrong direction when we have to correct it. So we put all these forces. These are the three things we have to find. This is DE, let me name FDE, and this is FDL, and this one is FML. So since we have this one here, so if you see this FDE and FDL, two unknown forces. So what I can do is I can take the moment around this part to calculate FML. So if I take moment around, this is D, right? This is D. So if I take moment around D, so we always take the moment around too many unknown, where there is too many unknown variables. So it's easy to get rid of them and solve the other parts, right? I take counterclockwise positive. If I take counterclockwise positive, total moment is 0, statics, and there we go. So in this case, we have, if we start from D, we have 12 kilonewton acting counterclockwise is 4 meter distance. So 12 times 4, and we have 6 Newton acting 8 meter distance. 6 times 8, and then we have AY acting on it upside counterclockwise. It's minus, and it's, we have found it 36 Newton, 36 kilonewton times the distance is same 8, and we have this FML. It's turning this object into clockwise, so it's also negative FML, and in this case we have to put the height. So how do we find this height? So if you look at the picture, this is 3, right? This is 3, and this is 6 in the middle. So it means 3, 4, 5, 6. You can just guess it, or you can draw a triangle here. It's going to be same thing, right? If you draw it from here or here, same thing. So for example, let's draw it. So here, and before it comes out, we have two different things right here, and this is 6, and this part is 12, or this is 3. I'm taking the only the top part, and it's exactly cutting in the middle. So 3, 12, and let's say this is y, this is 4, right? So if I find the ratio, it's going to be y over 4 equal to 3 over 12. Even if I multiply, I will get y is equal to 1. So if you do this for 8, you will get y is equal to 2. Like for example, if it's y prime, y prime is equal to 3 by 12 times 8, so you get 2. So like that, if you calculate, let's see, it means this is already 3 and 1 meter increasing, and here is 2 meter increasing, same thing from this one, so we know it's 5. Therefore we know this height of this m is 5 meter, so therefore I can multiply fml by 5. I have to know the horizontal, so if I calculate, I will end up with fml times 5 is equal to this whole thing, 12 times 4 48 plus 48 minus 36 times 8, this thing. And from the look at it, we know this is a negative answer, and let's calculate. So it's going to be 38.4 kilonewton. So FML is 38 point, if you calculate you will get this one, and since this is negative, our assumption is wrong and we have to change the direction. So FML, so this is actually going in this direction. So that's what we figured it out. 36 times 8, yeah, and it's divided by 5, and we got it. So this is the FML's direction, original direction. Then we have to find FDL and FDE. How we can find it? So since we have two unknown variables here, we have found FML, but I can take, like, I can extend this one to this line to find those things. So for example, I can take movement around E to find this FDL, or I can take movement around L to find this uh, FDE. So what I can do is, if I take movement around L, I can get rid of this decimal number and these things, so I can simply find the FDL, right? So I take movement around E, movement around L, so I can get rid of this FDL and FML, and I can directly calculate FDE. So let's take movement around L. I take counterclockwise positive 0. So if I do that, I will get, first of all I put FDE, and it's going to be cos theta, because it's not a direct line, so it's cos theta, so we have to find the angle. So in order to do that, I know the height is going to be 1 meter from here, and we know this is 4 meter distance. So if I find this theta, it's going to be, so cos theta is going to be opposite of adjacent. So to find the adjacent, I can use Pythagorean theorem. It's going to be 4 square plus 1 square is going to be root 17. Therefore I can multiply FDE by 4 over root 17, 4 over root 17, and it's coming from the height of 6 meter. This is 6 meter, and this is D, right? So I had to put this 6 meter to multiply. Then we have here 12 kilonewton pushing this object down. So it's counterclockwise, therefore it's positive. It's going to be 12 times 4 plus. And we have this 12 kilonewton pushing this object down for 8 from this L, right? So it's going to be 8 from the L, so it's going to be plus 12 times 8, and from the L, this 6 kilonewton is 8, 16, so 16 times 6 plus 16 times 6, 16 times 6, then then we have 36 kilonewton pulling this object up, so it's going to be 36 times same distance 6, it's going to be minus 36 times 6. So from the look of it, we know this is a negative answer, and if you calculate, FD comes out to be equal to, so this is 16 times 6, so this is also 16, right? 16 meter distance. So FD comes out to be 37.11, and if you look at it, it's going to be a negative answer. Therefore, we know the our assumption is wrong and the direction is opposite side. This is going away. So this is the original FD direction. Now I have only FDL is left. I can either find from horizontal components or vertical components, but if you see, we have too many vertical components. So horizontal component, we have only FDL and FML, FDL, FML, and FTE, three things. So it's better to choose horizontal components. So let's see, sigma fx is equal to 0. Since this direction is positive, if I take this direction positive, these two become positive. So it's going to be 37.11, and this is going to be cos theta. This is not in a not in a straight line, right? So 37.11 cos theta. The angle we already found, it's going to be 1 over root 17 with 4 over root 17 is cos theta. So adjacent over hypotenuse 4 over root 17, and then we have FTL cos theta. So FTL, that's what we have to find. FTL is going in the opposite direction, so negative. FDL cos theta is going to be, so if you draw this line is going to be the same. So it's, if you draw Z, this is the same, so it's going to be same as this one. So it's going to be, height is 5 meter and the width is 4 meter. So 5 square is 25, 4 square is 16, so 25 plus 16 is root of 41. That's my hypotenuse. So cos theta is 4 over root square root of 41. So this is my FT cos theta, and then we have ML acting on the opposite, oh, is in this direction, it's positive direction. So if I calculate ML, it's going to be, it's already calculated, it's plus 38.4 kilonewton is equal to 0. So from this one, by the look of it, we see we took the right direction. So the direction is not going to change. So if we calculate FDL, it comes out to be 3.8 3.848 kilonewton. So this is my answer. Let me check again. So 3.848 kilonewton. So this is my final answer. I hope you guys like this video. See you next time.